So in this module, we're going to talk about sets. And there's actually two reasons why I want to talk about them, okay? So reason number one is that sets are just used everywhere, okay? Are used everywhere in both math and CS, okay? So we need to know about them. We need to learn the way they behave, a lot of their properties, and so that's important, okay? The second reason that we need to learn about this, rather, is that we can reason about quantifiers. Okay, so we prove theorems that use quantifiers, but where we tend to get into stuck is in the details, okay? We get into trouble in details about specific things, okay? So it's actually easier for us right now to prove something that is true about P of x and Q of x, where we don't even know what P and Q are, right? Than it is to prove about x being an even number. And that's just because we don't have really good axioms about being an even number. We don't have any axioms about anything other than these general quantifiers and general propositional connectives, okay? So we can prove P or not P, but it's hard for us to prove 3 is odd. So that's why we're going to talk about sets, because that will actually give us some axioms, some rules that are true about sets, and then we'll be actually able to reason completely about sets, right, which is at the start. Then we'll reason about other things like relations, functions, numbers, okay? But for now, we're going to reason about sets, which are really some of the simplest objects that we'll encounter. Okay, so what exactly is a set, right? And a set is an unordered collection of objects, okay? And what does that mean? Well, it's unordered. That means the order doesn't matter. So the set that has 1 and 2 is really the same as the set that has 2 and 1. It doesn't matter what order it has them in, okay? And it's a collection of objects. And what that means is that duplicates don't matter. Because if you have 2 of the same, right, 1 and 1, well, that's the same object, right? So, you know, it's actually no different than 1 and 1 and 1. They're all just the same object. Okay, so that's those are kind of the fundamental things to know about sets. It is a collection of things. I don't care about the order. I don't care about the objects. Okay, now let's do that a little bit more formally. Okay, so what do we have here? The objects in a set are called elements. Okay, so that's an important word to know. A set has elements, or it has members. Right? They're just two different ways of saying the same thing, and a set is a collection of elements or members, okay? We said that a set contains its members, right? So again, this is kind of a technical term that we're defining. We're defining what it means to contain some elements, okay? And now this is a mathematical notation. We say A, and that means belongs to or in. A belongs to S, and that is true exactly when A is an element of S, okay? And A does not belong to S means that A is not an element of S. What I want you to understand is that something like A belongs to S, right? Another way of writing it could have been P of A comma S, right? This is a predicate, okay? And it is a predicate, like all predicates, that means that it is either true or false of an element and a set, right? So if you get an element and a set, it tells you whether that element belongs to that set or not, okay? Okay, so here is some notations that we have for sets, okay? So this set here, 1, 2, and 5, we're actually listing the elements explicitly. So the elements of this set are 1, 2, and 5. Here's another set. We're listing the elements, but we're leaving a little bit to the imagination. We're saying it's 1, 2, 3, dot, dot, dot. We're kind of expecting the reader, I guess, to understand that the dot, dot, dot means that 4 is an element of the set, so is 5, and 6, and 7, and so on, okay? This one kind of uses two different shortcut notations. You see the dot, 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 so plus or minus 3, plus or minus 4, plus or minus 5, but really what we're talking about is this set. It has minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on, right? So that it's got kind of two sets of dot, dot, dots, right? Okay, so that's one way of dealing with sets. We can name them explicitly what the elements are. Here's the other way, and we do it implicitly by giving a rule. So this set here, we said, and by the way, the notation that we're using is some kind of constructor. The simplest form is x, right? Such that, that's what the vertical bar is, and then some kind of rule. So this is like a pattern, and this is a rule, right? And the rule for the first one is there exists a k such that x is equal to 7k. Okay, so what is this set actually equal to? Well, let's see. 0 is definitely in there, okay, because there does exist a k such that x is equal to 7k. K is equal to 0. Another element that's there is 7, because there exists a k such that x is equal to 7 times 1, right? K is equal to 1. And 14, and 21, and so on, right? In fact, I would say that it should be plus or minus, because there is a k. Minus 1, minus 2, minus 3, that makes that happen, right? The only kind of discussion here is what is our domain of discourse? When I say there exists a k, am I saying that there exists a integer, a real number, a natural number, and so on, right? I think it's reasonable to interpret that as an integer, and I think that's what we should do whenever there's any ambiguity, okay? Now here's another one, 7k, where k is a non-negative integer. So in this case, our pattern is actually a constructor. So it's not k that I'm interested in, it's 7k, right? So k is a non-negative integer. So it could be 1, in which case we have 7. It could be 2, in which case we have 14. It could be 3, we have 21, and so on. Okay, so that's what that set is. So we have a rule that says k is a non-negative integer. That tells us the possible values of k that we'll consider. And for each one of those values, what we want to put in the set is 7k, right? Similar to that is this. We have a set, and the rule is p is prime, okay? So let's see, that means we have 2 is one of the prime numbers. So 1 over p should be in this set. That means that 1 over 2 is here, okay? 3 is the next prime, so 1 over 3 is here, 1 over 5, 1 over 7, and so on, right? All of those numbers are there. So those are just 2 different ways of specifying sets, okay?